All right, let's try doing a similar thing with some data. So here's another problem from the textbook, number 9.42, and on page 359. So the context is this is a small Subaru dealership. They leased 21 Outbacks on 2-year leases. The cars were returned at the end of the lease, and the mileage was recorded. Is the dealer's mean significantly different than the national average of 30,000 miles for 2-year leased vehicles, using the 10% level of significance? And so there's a little typo. That should be CE. Okay, and just a little note, this is in the textbook asks you to test whether the mean is significantly greater, which suggests we're doing a one-tailed test. Okay, and so since I'm not in class today, I want to keep things straightforward, and so I changed that to different. So that we're going to do a two-tailed test, and here's the data. You can see the numbers in the textbook, and I just typed those in. Okay, and Excel's over here. And I'll get it, and I'll bring it back. All right, so here is the data for mileage on these cars. You can see they're all in the tens of thousands, and there's 21 numbers. Okay, so to conduct a one sample difference of means in Excel, we just use our descriptive statistics, our data and data analysis tools, and click on descriptive statistics. Click OK, and then just input the data into your descriptive statistics window, and click. We got labels in the first row. We want summary statistics, and we want a confidence level for the mean. Okay, and this is coded as 95%. Forget what confidence level that they're asking for. Go back. 9.42. I apologize. Yeah, so they asked for a 10%. They want the test conducted at a 10% alpha, which means a 90% confidence level. So I'm going to go in here and turn this in. Okay, and then we just click OK. And we'll get the, on sheet 2, we get the results for that test. And so the average is 33,949, which is greater than 30,000. We don't know if it's statistically greater, if the statistical difference is, statistically significant. So Excel calculates the mean and the standard error, and the one sample t-test that we're looking at in chapter 9 has the mean difference in the numerator. So we can take the mean and subtract from that the threshold or the benchmark that we are testing against. So 30,000. I'm going to put that in parentheses. And then divide that by the standard error, which is MB4. Okay, so my t-statistic, t-calc, is equal to 1.52. Okay. Okay, so we need to compare that to the t-critical value. Okay, so the formula for the t-critical value, t dot inverse. This is a two-tailed test. So this returns the two-tailed inverse of the student's t distribution. Okay, so it asked me to enter the probability and the degrees of freedom. So the probability is our alpha, so 0.10. And degrees of freedom is equal to the sample size, or the count down here, minus 1. So to make that explicit, we could do B15 minus 1. And hit return. And this tells us that our t critical value is 1.72. So since the t-calc is less than t-crit, again, just like before, we've got a high hurdle. And here we come, and boom, we don't clear the hurdle, we drop, and so we cannot, and so we think that this number 34,000 is about the same as 30,000. So it looks like there's a difference, but statistically there is no difference. Okay, so another way to test that is with the, so that's the number one test that we talked about in lecture. The second test is with the confidence intervals. Okay, so with confidence intervals, we can calculate lower limits and upper limits. All right, and we want to find a 90% confidence interval. So the lower limit on the confidence interval is going to be equal to the B3, and then we subtract from that our confidence level calculation that Excel has done for us. And this number, which we'll check in just a second, is equal to the standard error times the t-critical value. Okay, so B3 minus B16 would be our lower limit, and then our upper limit is equal to B3 plus B16. Okay, so the confidence interval goes from 29,000 to 38,000, and 30,000 is within that confidence interval. So again, we would conclude that there's no differences in the two, in our 21 mileages and the national standard. Okay, and just to check, let's check to see if the number in B16 is equal to the critical value, which is E3. E3. Okay. Okay, so there it is. E3 times the standard error of B4. Yeah, so those two numbers are the same. So Excel's calculating the confidence intervals the way we think it is. Okay, and then the third approach is the p-value approach. Okay, with the p-value approach, we want to compare the p-value with the alpha. And in this problem, the alpha is equal to 0.10. The p-value is going to be equal to t.dist.2t. Okay, that returns a two-tailed student's t distribution. So we're going to open up the parentheses, and it wants an x value. So that is telling us it wants the calculated t statistic. So we find that in D3. Okay, and then comma, and then it tells me it wants the degrees of freedom. And again, that's the sample size minus 1. So that's B15 minus 1. Hit return. So the p-value is 0.14. Okay, 0.14 is greater than 0.1, so we would conclude that there's no difference. Okay, and that's the same conclusion that we got from the confidence interval approach and the t-statistic approach. Okay, these answers should always line up. You should always have these three approaches to this test should always give the same result. Okay, so now let's do this with SPSS. We'll use the same data set, and so I'm going to save this. I'll save it to my desktop. So that's chapter 9, problem 9.42, and that's mileage, and it's the second time I've downloaded today, so it gave me a little number there, so I'll just save that. And I'm going to close Excel because SPSS doesn't like when we try to import Excel data when the data file is open. All right, so let's see. Okay, so here's SPSS. I've already opened it up. If you are, just to remind you, if you are just starting your computer, if you click on the that thing in the bottom left corner, IBM SPSS statistics is what you're looking for. Okay, but if you download the data set from the lab, SPSS will just open up. Okay, so here we are in the data editor window. If you click on File, Import Data in Excel, and then look for your data set. Let's see, that's on my desktop. Okay, and so if you highlight the file you want to open and click Open. Okay, so now it has read the Excel file and it's given me, oh, and I'm like, oh, I'm on sheet 2, which is the output. I don't want that. So if I go up to the worksheet here at the top of the Read Excel file window and click on that down arrow, and maybe my data will be in cell 1, sheet 1. Yes, and there it is. So if I just click OK, SPSS will bring that into my data editor. Okay, and then the first thing I want to do is File and save that data set. So here, some new data. This is problem 9.42. Okay, so I've saved it now and I'm not going to lose any work. All right, so the one sample t-test, or test for differences in means in SPSS, is conducted from the Analyze menu. So if you left mouse click on Analyze and then come down to Compare Means and highlight that, then you'll be given a bunch of options. Okay, we'll be using a lot of these options for the next 3 chapters. But the one we want now is the one sample t-test. So if you click on that, okay, a window that looks like this will pop up. Okay, we only have one variable here, so that's easy. You highlight that one variable, click on the right arrow. Okay, and you could click OK, but what you're doing is testing to see if the mean of mileage is different from 0. They've got a little test value box down here, and this is for the mu naught. That's in our that's the notation for our textbook. So the test value is where we want to type in 30,000. Okay, and then let's make sure we know what we're doing up here. Click on Options. Oh, and the baseline, it's set up to give us a 95% confidence interval. But the problem we're working on, the answer we need is for the 90% confidence interval. So I'm going to type 90 and just continue. And that's pretty much it. Click on OK. And you'll get some answers in your statistics viewer. A new window pops up. You'll get your statistics viewer. Okay, so here's the t-test. One sample statistics. Here we have a sample size of 21, a mean of 34,000, just like we found in Excel. Okay, we've got a standard deviation and the standard error of the mean. All those numbers are just like we have found in Excel. Okay, so the t-statistic is 1.525, just like in Excel. Degrees of freedom is 20. And SPSS does not give us the critical value of that t-statistic. Okay, it turns out that most statistical software recognizes that you don't need that. Okay, it'll give you a p-value. Okay, and they call the p-value the significance value, and it's always set up to do a two-tailed test. Okay, so the p-value that we have here, 1.43. I think that's the same as what we got in Excel. But this is telling us that there is the p-value, if we're doing our test against 0.10, the p-value is greater than 0.10, and so we would conclude that there's no differences in 34,000 and a mean of 34,000 and our benchmark of 30,000. Okay, so SPSS calls this the significance level, And this would say that there are significant differences. The interpretation of this is that there are statistically significant differences, but we'd have to go out to the 0.143 level. So basically we could conclude that this is different from the benchmark, but we'd only be 85.7% confident, which is 1 minus the significance level. Okay, the next value, so here's a test value presented in the one sample test, 30,000. Okay, and then the mean difference between those two is 3,949, 3,950. Okay, and what we're going to do is ignore this 90% confidence level. This gives us the 90% confidence level for the difference, this mean difference here. So let's ignore that. Okay, and we're going to do the confidence interval approach with a different set of, with a different option. All right, so to do the confidence level approach, confidence interval approach, click on Analyze, and then Descriptives, and then Descriptives. Okay, and just kick your mileage over. No, not Descriptives. I'm getting tired. Descriptive statistics, and then Explore. Explore will give us a confidence interval. So click on Explore, and find your mileage. Kick it over to your dependent list, and then let's just don't have a lot of mess in our outputs, and click on Statistics. We don't want the graphics, the plots, and then click on your statistics button, and this already has the confidence interval for the mean checked. It'll give us that automatically, but what they want to give us is the 95% confidence interval. So let's use the 90% confidence interval. So click Continue, and then OK. All right, and so the descriptive statistics, that they'll give you a bunch of numbers. We've looked at these before. The mean for the mileage is the first number you get, and we're getting used to seeing that number. Then the 90% confidence interval for the mean ranges from 29,000 to 38,000, and that's I think that's identical to what we calculated in Excel. Okay, so one thing, if you have some output, you probably don't want to punch in your numbers or just assume that your output's going to be saved somewhere. You might want to keep that. So one way of keeping your output, your answers, is to save this to a Word document or a PDF document. So I like to do it to a PDF document. So I would click on File, and you can export your answers. And here we have the Export Output dialog box. And so the document type, I think I already saved something as a PDF, so it's got portable document format already ready to go. But you might not want to save it like that. So if you click this down arrow, you could save it as a web report, basically an HTML set of files. You could save it as a PowerPoint, a Word document, or what I'm going to do is save it as a PDF. Okay, so now don't run off and do your lab yet, because I'm going to ask you to upload your output. So I'm going to ask you to do this. Okay, because I'm going to want to take a look at your output compared to mine. Okay, so and then don't forget to put this in a place where you think you will find it. Okay, this path is based on the last output that I saved. So that's in my on my P drive, in my teaching folder, in my Eco 2200 folder, and then this semester, Spring 2020, in my lab folder, and this is the Lab 1 output. And the last one I saved was the Lab 1 output. Okay, so I don't want to do that. I want to call this something else. This is problem 9.42 output. right, and so if you want to change where that is going, which you probably will based on how they have this set up, just click Browse and you can put it to your desktop or somewhere else. Okay, so then if you click OK, let's see, did it pop up as? Yeah, that showed up that's in my folder. I'm not going to pull it up because I'm running out of time here. Okay, so the lab answers go into the survey form. This is a Qualtrics survey, so tell me your name. And this lab is adapted from problem 9.78 on page 381 of the textbook. So here we have a quality control problem. The sodium content of a popular sports drink is listed as 220 milligrams in a 32-ounce bottle. Analysis of 10 bottles indicates a sample mean of 226 with a standard deviation of 16. Okay, and this is the variable sodium underscore N10 in the sodium.save dataset. Okay, and then we weren't happy with that small sample, maybe, and so we did a further analysis with 94 bottles, and for that analysis we found a sample mean of 229 with a standard deviation of 17. And that's the sodium, I think that's N94 variable in the data set. Okay, and all the questions below for a two-tailed test. And so first, what is the mean difference for each sample? And for the answer here, you need to calculate the difference in the mean versus the benchmark. Okay, and the one sample t-test in SPSS will give you those answers. Okay, and then so the first thing we want to do is test the manufacturer's claim for both samples with the t-statistic approach. So first, compare the t-statistic, and that's t-calc from the notes, to the t-critical value at the 5% level of significance. Okay, so your answers to t-calc for n is 10 and t-calc for n is 90 equals 94. You get that from Excel. For the critical values, you can use Excel, the formulas that I just illustrated, or you can find those numbers in the back of the book. Okay, and then answer the question at the 5% level of significance: does the sample contradict the manufacturer's claim, considering the t-statistic approach? So yes, okay, or no. Okay, so you can only have one answer for n equals 10 and n equals 94. Okay, and then the second question, since you're going to get the p-value out of the SPSS command that you just used to find your t-statistic, okay, do the same test with the p-value approach. So this is the sig level, significance level in SPSS, and so just find that number, just punch it in there, and then interpret that and see if the sample contradicts the manufacturer's claim. Okay, and then the last test, we're going to do the confidence interval approach. So calculate the 95% confidence interval to test the claim. So find the lower limit for n equals 10, find the upper limit for n equals 10, and the lower limit for the larger sample. And you do this test with the analyze, descriptive statistics, and explore command in SPSS. And then answer the same question at the end. Yeah, do you think there are statistically significant differences or not? All right, so good luck to everybody, and I'll see you next week.